Hello, everyone, and welcome to this premiere episode of Building SaaS on AWS. My name is Gunnar Grosch, and I am a developer advocate here at AWS. And in this series, I'll be joined by SaaS specialists to dive deep on technical content around building SaaS on AWS. And we'll look at reference architectures, specific use cases, AWS customer examples, and a lot more. And the goal is for you to learn how to build that next generation SaaS on AWS. But compared to a webinar or an event session, building SaaS on AWS is going to be as interactive as you make it. So this is your chance to get all your SaaS-related technical questions answered, and you'll do that through the chat. So give us a quick hi to start things out in the chat. And I've told all of my guests that we don't want to see a lot of slides. We want to see code. We want demos. We want to see services in action on building SaaS on AWS. And we're going to jump straight into it, straight into the deep end of the pool. No fussing about. So this is going to be deep technical content from the beginning. And today, I'm joined by Ranjit Raman. He's a senior partner solutions architect at AWS. So welcome to the show, Ranjit.
Yeah, thanks, Gunnar. Thanks for having me.
So tell people just short intro to who Ranjit is.
Yeah, sure. So my name is Ranjit Raman. I'm a senior solutions architect with a team called the AWS SaaS Factory. So I've been with the team for a little over 2 years now. And so SaaS Factory, what we do is we are a group of SaaS business architects and technical solutions architects like me. And what we do is we help organizations that could be at various stages of their SaaS journey. So we go out, we provide just best practices and design or help with design and recommendations on how you build SaaS solutions. So so that's a little bit about me and also the team that I'm on.
All right, and that is why you are well suited to be on this show. And today we are going to do a deep dive. Tell us a bit about what the subject for today is, Ranjit.
Yeah, sure. So it's going to be how you're going to how to build a multi-tenant SaaS solution on top of Amazon Elastic Kubernetes Service, right? So or Amazon EKS, and this is a topic that came up that we have heard during our customer conversations. Especially the customers that are building containerized workloads or have containerized applications. And they're looking at Kubernetes as a orchestrator, container orchestrator, or Amazon EKS, which is the managed offering of Kubernetes from AWS. So they were asking us, okay, so how do you build a multi-tenant SaaS solution on top of EKS? And we in our team, we were looking at, we were just researching it as well, and we saw this really strong alignment between some of the foundational SaaS concepts that we always talk about and what Kubernetes had to offer, just in terms of multi-tenancy and isolation and all that. So and there was a really good alignment. And just if you think about just the rise of containers, right? So if you go back a few years where you had to provision a VM and or just rack and stack servers, and imagine how long that takes. But containers, change the game, right? So you're able to spin up tens and hundreds and thousands of containers within moments, and that is very appealing for SaaS customers and SaaS providers. And we saw that because SaaS workloads in general, they tend to be really spiky or bursty kind of a workload, right? So the ability to rapidly scale up and down was very appealing to a lot of these customers. And then just in terms of the security constructs that Amazon EKS adds, it adds a layer on top of vanilla Kubernetes, where it provides native integrations with things like IAM and things like that, services like that. So that is very compelling because in a SaaS solution, you want your tenants to be isolated, and your tenants' data to be isolated and all that. So the security aspects of it was very appealing to us, and also the SaaS providers that we were talking to, and just the whole community, right? Kubernetes community, it's very vibrant. It's very active. There are a lot of toolings that comes out of the community, and we have used tools like Tiger's Calico in the solution, and just the Nginx ingress controller. So we have an active community there, right? So those are all the reasons that we started looking into the solution. Customer asks, and then the ability to rapidly scale up and down, and cost efficiency, and security, and just the whole community aspect of it. So yeah, so that's why we sort of built this reference architecture, and it's open source. It's available on GitHub, and there's a repo and all that. So
that's awesome. So for the episode today, we're going to dive deep on that reference architecture with Ranjit, and he's going to walk us through how it works and what the benefits of it are. And if you are not into EKS right now, just a quick tip that the next episode in 2 weeks is going to be a similar episode, but instead reference architecture on building serverless SaaS. So come back next week or in 2 weeks as well to watch that. So Ranjit, so let's then let's look at what are some of the key aspects, if we look at it from a technical standpoint, that people need to keep in mind when they're building any type of SaaS application?
Yeah, sure. So when we talk about a SaaS solution, so one of the first things that comes to mind is this whole this whole notion of multi-tenancy, right? How are you going to build a multi-tenant application? How are you going to sort of collocate your tens and hundreds of tenants into this shared or a pooled infrastructure? And you're sharing compute, you're sharing storage, and you might be sharing other network constructs, right? So the whole notion of multi-tenancy is what a lot of people look at. But what we, in our team, what we say is there are all these surrounding bits that are important as well. Things like the ability to onboard a tenant. We call it frictionless onboarding, where which is nothing but the moment your customer or tenant signs up for a SaaS product or SaaS application, how soon are they able to realize value from that product, right? We call it the cycle time, and that time should be really low. And you need to have a good onboarding pipeline for that, right? And then we also talk a lot about, authentication. How are you able to establish identity for your tenant, right? So because if you don't know who is coming in, how are you going to secure their resources or data and their workloads, right? So authentication is another aspect that we focus on a lot. And once you have that, isolation, tenant isolation using different constructs. And in the solution, we because Kubernetes provides, like I said, it provides some really good isolation mechanisms like namespaces, and we will talk about that. But namespace is a really good model to isolate your tenants and their workload. So we do that. And then just in terms of storage, right? So you may want to partition a tenant's data and then isolate after that, right? So you're looking at data isolation as well. So those are some of the key things. And also there are other bits like metering and billing, right? So you want to know which tenant is using how much of your resource, right? So you want to calculate that and keep track of that. Metrics and analytics, things like monitoring, because monitoring is such a critical aspect of a SaaS product or a SaaS application, because it's your team that has the pager now, right? I mean, you're supporting all these different tenants. It's such a different model from how on-premises software, and because it's a customer's team that's monitoring and doing all those kinds of activities. But now it's you that does that. So SaaS sets a really high bar for monitoring and really high bar for DevOps. You don't want your application to go down, right? So that's we call it the SaaS architecture landscape. And I have the slide that talks about or shows all these different components like onboarding and authentication and metrics and all these other bits. So that particular slide that you see, right? So yeah, so, that's yeah.
Yeah, right. So these are the things you just mentioned, and we're not going to cover all of this for this reference architecture, right?
No, we are not. So we're just going to cover the the parts in the middle, the onboarding, authentication, and how we isolate. Like I said, this is the first iteration of this reference solution. It's open source, so we are still building it out. So things like billing and metering, metrics, those are some features and capabilities that we are that we are adding, right? And like I said, it's open source, so we welcome a pull request, PRs from people. If you're interested, please feel free to contribute as well.
Right. So we're 10 minutes into the show with Ranjit. This is building SaaS on AWS. And now I think it's time to start diving into the actual reference architecture. So where do we start, Ranjit?
Yeah. So so I want to show you a conceptual view of the stack first, right? So and we based this out of, so imagine you're a SaaS provider and you're just providing e-commerce applications or e-commerce, sort of like a storefront for your tenants or for your customers, right? So let's say I'm a tenant and I want to sell flowers, right? And I want my own my own website, my own subdomain as part of this tenant provider. So it would be like let's say flowers.saasproviderdomain.com, or if there is a different tenant that wants to sell shoes, right? So it would be shoes.saasproviderdomain.com. So that is sort of the a really simple e-commerce kind of an example that we went with for the solution. And on the top you can see that.
Can you just press the presentation button so it makes that view a bit bigger?
Oh yeah, absolutely. Yeah. So
I think it makes it easier. So I said initially that we're going to not have that many slides, but I think this is important to view slides for these conceptual views of the architecture, and then some more architectural slides as well.
No, absolutely. That's a good point. Oh, thanks, Gunnar. Is this better?
This is great.
Awesome. Yeah. So, like I said, I mean, it's a really simple e-commerce kind of a solution, right? And what you see on the top is, I'll start from the top left. It's a landing page or a sign up page, right? So if you're a SaaS provider, this is your marketing page, for example, right? Where if I'm the tenant, I would go to this page, and this is where I'm going to find some kind of a registration form or register button or a form where I can enter my details and just apply, right? Or just start the onboarding process, right? So that's the landing application, and the one in the middle is the SaaS application that I would get after I'm on board or after I'm registered into the product, right? So like I said, I want to sell flowers, right? So at the end of the process or at the end of onboarding, I would get my own space or own website or own subdomain called flowers.saasproviderdomain.com, right? And we use Amazon Cognito here. So like I said in my intro slide, or one of the early slides, authentication is an important aspect. And if you're building a SaaS application, as much as possible, try to leverage some of the identity providers that are already out there, because we have they have done the heavy lifting for you, right? So in this case, it's Cognito, but technically you can use any IDP that you prefer. So and further towards the right, there is the SaaS provider admin console. So that's really, if you're the SaaS provider, you may want your admin to have an application where they can, watch or see what your tenants are doing, and just monitor. I mean, it's more like a meta view of what's happening in the system, right? You may have dashboards and visualizations and things like that. So those are the client applications. Those are the websites that we have. And then down below, that's the shared Amazon EKS cluster, the Elastic Kubernetes cluster that we have. It's a pretty standard cluster, and I have a slide where I'll show you the layout, the architecture of that. But what we have is the shared services, and these are like the horizontal services, that has cross-cutting concerns, right? Because, like I said, when somebody signs up and clicks on the register button from your landing page or from your marketing application, it calls the registration service, right? And registration service calls the user management service, right? So those are some of the shared services that we have already deployed. When you spin up the stack, you would get those services, right? So you would deploy those services. And the one on the left, bottom left, are the application services, because, like I said, every tenant gets their own sort of e-commerce, website, right? So you need backend services, and we have a couple of services that we provision when we onboard the tenant, right? So product service and order service get, during onboarding of a tenant, you would deploy these, couple of services. So that's the conceptual view of the stack.
But that also shows that this is a real solution. It contains all of the different parts you really need to have this SaaS solution up and running.
Absolutely. Yep. So and like I said, this is an open source solution. It's out there on AWS samples, and there's it's a GitHub repo that you're able to clone and download and all that. So when you spin up the solution, so you're going to, that's a good point, Gunnar. It's a sort of a segue into this baseline environment, right? So when you spin up the stack and run the deploy script, you're going to get a baseline environment, which consists of, the websites, the client websites that I was talking about, that I was showing in my earlier slide, but also the EKS cluster. And this, if you look at it, this is a pretty standard, high available AWS kind of an architecture, right? So you have a VPC, and you have a public subnets across the different AZs, and then private subnet, right? And you have an EKS cluster, and then the shared services are deployed into a shared namespace, right? So when you spin it up, the shared services are already deployed. All the toolings like kubectl, which is a CLI to interact with the Kubernetes cluster, that is already deployed. Things like Helm, that is deployed. And if you see on the top, there is Route 53 and there's S3 bucket. So that's for we deploy the client web code. It's Angular. We use Angular. So all that is in the S3 buckets, right? And then we also create Cloudfront distributions for the three applications, the client applications that I was talking about. And I can show you all that bits in a shortly. And you also see that there is a network load balancer, and there's an N, which is for Nginx ingress controller. And so the controller is sort of the central aspect of this whole architecture, and we can dive into why that is the case. And down below, we can see we use Amazon DynamoDB. I mean, it's just for storing the tenant data, right? Capture the tenant details, and we store that in DynamoDB. And there are other things that we store in DynamoDB as well. And DynamoDB, it's a NoSQL key value kind of a solution, database solution that we have. And obviously, like I said, we use Amazon Cognito as part of this solution. It is used as an identity provider, and this is what we use for authentication and authorization for the tenant's users. And I'll also cover that aspect. So so this is like, when you provision, when you download the repo, and when you start the deployment, and once the deployment ends, you're going to see something like this. You're going to get an EKS cluster, and also the websites and all the other infrastructure constructs ready for you. And then you're ready to onboard tenants. And that's where I already have the example, the infrastructure installed on my account. And I can show you what's the next step, how do you onboard a tenant next.
So how much of the baseline environment is specific for this example e-commerce site, and how much of it could you basically use to use any sort of add any type of tenants to it?
Yeah, so adding tenants, it's the way we have it set up. It is like I said, you would go to SaaS provider's marketing page or a landing application. So which is right now, when we created the baseline environment, those applications are already live and up and running, right? So that and I can show you how that looks like. So you would basically, like if you're the tenant or a customer that wants to sign up or wants to create a storefront with the SaaS provider, you would basically go to that landing application, and then you would go enter your details and hit the register button, and that would kickstart or start this whole onboarding process. It would call some of these services that we have, the registration, user management, and all that. So yeah, that's how that process works.
Yeah. All right. So next then, I think you have a third slide, right?
Yeah, so I wanted to show how a tenant environment looks like as well. So, right, so we provisioned the,
so when from that baseline environment, when you then onboard a tenant, it will then spin up these tenant environments for each tenant. Is that right?
Yeah, that's right. Yeah. So you have the baseline environment up and running. You have the websites, the landing application, and all those, the admin application already up and running. You have the EKS cluster, and you have the shared services that I showed you already up and running, the network load balancer and all that, right? So now when a tenant is onboarded, and this is, this is where you deploy their services, their workloads, right? So like I said, it's an e-commerce solution. So each tenant gets their own, a product and an order service. And that's what you're looking at here. And we are still using the same EKS cluster. But what we do is we create a namespace for every single tenant gets their own namespace in this model. And when I say namespace, it's a Kubernetes namespace. And we found the construct of a namespace really compelling and just appealing to SaaS providers. And when we talk to customers, they also like this construct of a namespace because it gives you that isolation sort of a boundary. It's almost like a virtual cluster inside an EKS cluster, inside another cluster, right? So, and then what you're able to do is once you have a namespace for a tenant, you are able to deploy their workloads into that namespace, right? And you're able to secure them using things like service accounts, and you can create secrets and all that, right? So we found that it's a really good model because if you think about just so there could be you may have a customer or a tenant that says I just want to spin up my own EKS cluster because I don't want to share my workloads with other tenants of yours and all that, right? But imagine and you start doing that, but imagine you have hundreds and thousands of customers and tenants, and you keep doing that. You have all these clusters that you have to manage. I mean, it's fine. I mean, you can have a management tool and but just in terms of operational efficiency, it can get harder. Yeah. So that's why we think a namespace is a good isolation model, and maybe you can have some of your tenants that are in a specific tier. You can create a namespace per tenant model. So yeah.
All right. So let's then start from the beginning with this. If I were to use this reference architecture, could we just go, you mentioned that it's open source, it's available on GitHub. Can we go to the GitHub repo and have a look at where do I start with this and what are the components that I'll use?
No, absolutely. And there's also this blog that we have written, and we can put the link for this blog in the chat window, right? So, and we it's me and one of my colleague, Toby Buckley, that built the solution, and Todd Golding, who is one of the principal architects in our team. So he helped quite a bit in terms of the design aspects as well. So definitely go read this blog when you get a chance, and it walks you through a lot of the things that we are talking about, or I'm talking about here. So Gunnar, you asked about the GitHub repo. So this is the GitHub repository, right? So it's under AWS samples, and it's called AWS SaaS Factory EKS reference architecture. And there is a README, a setting up environment, and just a few steps. I mean, you can have this whole stack up and running like within a few steps, right? Or in a few steps, like first is, I mean, it's like 7 steps, right? But if you want a detailed view of what's happening and what are the different components, there's also a developer guide and I can just click that. And if you see here, it will take you to a developer guide where we walk through at detail, right? What are the components in the baseline infrastructure that I was talking about, right? So every single components in the baseline infrastructure, and then also all the different components in the tenant infrastructure, right? So what do we do there? So we talk about all that and routing. So it's pretty detailed and extensive documentation of the solution. So so we have that as well.
Yeah, I've shared both the links to the blog and to the repo in the chat. I hope you're able to access it there. So let's start from the beginning then. Look at the first part of what the deployment looks like.
Yeah, absolutely. So, I mean, like I said, one of the prerequisites when you download this repo, just one of the prerequisites is that you need an external domain, right? So this is the SaaS provider's domain, right? And you can either you can use your existing domain, or you can get a really cheap domain from one of these websites. But so that's kind of the prerequisite. But once you have your external domain, you would create a hosted zone. So what we call a hosted zone inside the Route 53, the Amazon Route 53 service. And then there are some steps here that you can just go through. I mean, what we are doing is essentially taking some of the names, the name server records from your newly created hosted zone, and you'll have to transfer that to your domain that you have, your external domain, right? So that way we know that, like, when you hit that, it gets routed to, when you hit the URL, it gets routed to the right host zone, right? So this is kind of a sort of a prerequisite kind of a step, and you would create a hosted zone and associate that with your domain, right? So once you have that, you would have obviously you have a hosted zone ID that looks something like this, and then you would basically, I mean, these are some of the steps you can do. You can use your own ID, like a terminal, or like if you have other tools, you can use that as well. But here we are using Cloud9, which is a Cloud IDE offering or a tool from AWS. So and I'm going to show you that. So I'm going to use Cloud9 to interact IDE to interact with my Kubernetes cluster. So so you would provision that and assign some roles, EC2 instance roles, and then basically what you do is there's this setup script, right? So we kick off couple of scripts to start the process. There is this setup.sh script that you see here. So we kick that off, and then a deploy cluster script, and then finally a deploy script. So this is this deploys all the applications, the client, the websites, and all that. And deploy cluster, like the name says, it deploys an Amazon EKS cluster. And then and there are some setup things that you would do, right? So that at a very high level, right? And those are all the steps that you would need, and you'll have this whole thing up and running within a few minutes. I would say about last we saw it was about 45 minutes or something like that, and you'll have the entire baseline infrastructure up and ready within that time.
So let's jump into one of the scripts. Let's look at the deploy script to see what it actually deploys and what the components are.
Yeah, sure. So this is actually let me go to the. So like I said, we start off with the setup.sh script, and what it's doing is it's basically setting up some of the toolings that you would require, right? So it's creating some of the helper tools like kubectl that I was talking about, and EKS Cuttle is another tool that we use to we use EKS Cuttle. It's a tool that was created jointly by AWS and this company called vWorks, and it provides a really easier way to create an Amazon EKS cluster, a really nice abstraction. So we use EKS Cuttle, and basically the setup script goes through and installs all the toolings that we need, and we use Angular, and there are some key pairs that we use, and some KMS keys and all that. So that's what the setup script does. And this is one of the first things that you'll do, as in terms of installing this solution. And then, like I said, there is a deploy cluster, and so deploy cluster script, and this is where we use EKS Cuttle, and this is how the cluster looks like. A very simple, EKS cluster, a 3-node cluster, right? And we'll have to. So when we did this, the version was 1.17, but there are new versions, so we'll have to upgrade that. So that's a deploy cluster script. And the deploy script is where some of the heavy lifting happens, right? So this is where and if you see here, it takes an email address, you provide a stack name. The domain name is the external domain that you created. So remember, I was talking about you need an external domain, right? I have a domain for. I'm going to show you a little demo, and I do have a domain already created and it's ready. So if it was me, I would be passing that domain. And then the hosted zone ID. So this is the Route 53 hosted zone that I showed you, in the first step that you have to create, right? So it's that. So you basically provide those 4 values, and what the script does is it would go and basically, just create the sites, right? So for example, if I scroll down, so those are all some prep things that you do, right? So there's S3 buckets. So we, take all the Angular files, the front end, the client application, right? So we have that in an S3 bucket, and then we also create an ACM. Like we use the Amazon Certificate Manager to create a certificate, and that certificate is associated with the network load balancer, and so that's what this one does. So there's a Lambda that actually provisions that certificate, and the certificate is also attached to the Cloudfront distributions, because like I said, the S3 bucket would have it acts like the origin, so where you have all your client files or your application, the front end application files, and then we have three Cloudfront distributions: one for the landing page, the SaaS provider's landing client application, and then one for the admin, and there's one for the SaaS application that you create, right? So there are 3 Cloudfront distributions, and we associate the certificate that gets created as part of this Lambda to the distributions, and then finally we just invoke some more scripts, and this is where, for example, I can pull up build and upload websites, right? So if I pull up build and upload websites. So this is where so we basically look for the S3 bucket that gets created, and if you see here, we are installing Angular, right? And we just deploy the client application, the admin side, the app side, and the landing side. So this is where it's going to be created, and so we're going to push all the files to the bucket. So that's at a high level what the deploy script does. It goes, it takes a little bit of time, so you'll have to look at it closely and just walk through and follow all the different steps. But at a high level, what it's doing is it's spinning up the baseline infrastructure that I was talking about earlier, right? So the websites, the 3 client applications, and it creates the EKS cluster and all the toolings that are required to interact with that cluster. Provision Cloud9, which is the IDE, right? And things like the network load balancer, the controller, and all that is being provisioned by these, really by those 3 scripts, right? So a setup.sh. So if I go back to the base, so you have a setup and a deploy cluster and a deploy.sh, and so those are the 3 scripts that you would need and kick off, right?
Right. And for your demo environment, of course, you've gone through all of these steps. I'm going to ask you to jump into the AWS console, perhaps, and let's have a look at that EKS cluster that's been provisioned. And in the meantime, if you just join us, this is Building SaaS on AWS with me, Gunnar Grosch, and we are doing a walkthrough of an Amazon EKS reference architecture for multi-tenant SaaS on AWS. And Ranjit has, well, spent 35 minutes walking through a lot of the different parts of the environment. So if you just joined us, don't worry, this will all be available on demand as well, so you can go back and watch it. If you have any questions, though, feel free to post those in the chat, and we'll do our best to answer those throughout the session. All right, so that's Cloud9.
Yeah, so this is the Cloud9 IDE that I was talking about, and and we already have this provisioned as part of our baseline infrastructure that I was just walking through and we were talking about, Gunnar. So and remember I mentioned kubectl. It's a tool that is used to interact with the EKS cluster. So that is installed. And remember when I was showing you that EKS Scuttle configurations. So we create a 3-node EKS cluster, and these are the worker nodes, right? So the one good thing about using a managed Kubernetes offering like EKS is that the control plane is managed by AWS, so you don't have to worry about the control plane at all, like the API server or the Kube API server or the etcd, which is the persistent store. All that is taken care by AWS, and all you have to worry about is just the worker nodes. And even the worker nodes, you can use managed node groups, and AWS can take care of the management of the worker nodes as well. So what you're seeing here is really I'm interacting with the EKS cluster that I provisioned, and you're looking at a 3-node EKS cluster here.
Cool. All right. So, and as you mentioned before, you're using Cloud9 now, but of course you can use your own IDE if you wish and your own CLI. But
absolutely,
it makes it easier to use Cloud9 with this solution.
Yeah, definitely. Yeah.
So I have a question about the solution. You showed the architecture before, and you mentioned that it's using Nginx. Can you tell me a bit about why you went for Nginx and not using application load balancer, for instance, instead?
No, that's a great question. And this was something that we were debating. When we were building the solution, me, Toby, Todd, like when we were doing this last year. So we went with Nginx ingress controller, because at that time, like sometime in late last year or during fall when we were putting the solution together, the ALB ingress controller that AWS has, it did not support a single load balancer for different namespaces. So like I said, in our solution, we create a namespace per tenant, right? So every tenant gets their own namespace. But what used to happen, and what used to happen was for when you provision a namespace, every namespace gets its own load balancer, like an ALB, right? And and that was something that we didn't want to do. We just wanted like a single load balancer, and have the ability to route with that single load balancer to the different tenant namespaces. And at that point, the ALB ingress controller did not have that feature when we were building this. So, and we looked at other solutions, and Nginx ingress controller had the ability where you can do just what I said, right? So you can have a single load balancer, a network load balancer, and route the request. But now the ALB ingress controller, last reInvent or late last year, the ALB ingress controller has that feature similar to Nginx. So now you're able to use a single load balancer and have the ability to route to multiple namespace with an ALB ingress controller. So if you're building a solution today, I would actually recommend use the ALB ingress controller and not. You can use Nginx. That's fine. It totally works. You can see that it works, but ALB ingress controller would be my choice, right? And there is like I said, we are working on this, and it's incremental. So we have plans to move from Nginx ingress controller to an ALB ingress controller pretty soon. So that's in the works already.
All right. So But you're also accepting pull requests, right?
Yeah, absolutely. Yeah.
Yeah.
So if somebody is wants to contribute and create a PR against a repo, so we'd be happy to take a look at it. So definitely.
That's cool. All right, so we have the baseline environment up and running. I think maybe jump into a demo looking at what the solution looks like when we want to onboard a tenant and what happens behind the scenes.
Yeah, absolutely. So I'm going to go to the landing. So remember I mentioned this a few times, right? So a landing application. And so this is your SaaS provider, right? AWS Dev Shop. Assume that's the SaaS provider, right? So that's just one of our domains that we have. And this is I'm a tenant, like I said, and I want to sign up and have my own storefront with the SaaS provider. So what I'll do is I'll come here. I'll just click on the sign up button, and I'll try to. Okay, so I'm just going to try to create a user. I'll create a user. And I have to provide a valid email address because, like I said, behind the scenes, we're using Cognito, Amazon Cognito. So Cognito sends a temporary password to an email address, right? So this has to be a valid email address, and I'll just provide mine. And the company name, I'll just do, I don't know, SaaS Coffee, because it's 6 a.m. in US Pacific right now, and I need a coffee, so I'll just go for that. And then I'll pick one of the plans. So typically in a SaaS application, right? So you're going to see different plans, right? So you provide your tenants to pick a basic or an advanced or a premium plan, and each of those plans has its own sort of capabilities, right? So that's something that you would see in most SaaS applications, right? And then I just want to sign up for this solution, and I'm hoping in a few minutes I'll have my own storefront under my name, SaaS Coffee. So it would be like saascoffee.awsdevshop, which is the SaaS provider.com. So what we do is for every tenant, we create a subdomain that the tenant is able to access to. So Gunnar, what's happening at this point is, it must have triggered a call to the shared services that I was talking about earlier. The registration service, the user management service that we have already deployed in our EKS cluster, part of our baseline infrastructure provisioning. So I want to just quickly maybe show a slide of the onboarding process. So this is what we did right now. So we had a tenant that went and registered and entered the details and hit create or register, right? And that triggered a call to the shared services, the registration, user management, and tenant management services that's inside the EKS cluster. So this is what is happening behind the scenes. So behind the scenes, what is going on is, first of all, the registration service would create an alias in the Cloudfront distribution. So remember, I talked about having 3 Cloudfront distributions for front end for the client applications. So the registration service is actually doing that, creating an entry for SaaS Coffee as an alias in the distribution, and it also creates a Route 53 entry for SaaS Coffee because it's a new subdomain. So you need to have an entry in Route 53. For that subdomain to access its backend services. So that is happening behind the scenes. And what is also happening, the user management service, it creates a user pool for this tenant. So, and that is something that something we do as part of the solution. We create a user pool per tenant model. Every tenant gets their own user pool. Right.
Yeah, and I think that's an interesting thing to just stop for a minute with.
Sure.
Talking about isolation, in this case, it's user isolation. Then, why did you go for user pool per tenant?
Yeah, no, that's a great question because you could just have one user pool and have all your tenants and their users in that single user pool. And that's a great model. We have seen that model as well, right? So that's fine. But a user pool per tenant gives you that flexibility if you want to have, different password policies, stricter, looser password policies per tenant at the tenant level, right? Or if you want to have like multi-factor authentication per tenant, you want to enable it for some, you don't want to. So if you want that kind of a flexibility, creating a user pool per tenant model is a good model. But again, you have to, like, if you have hundreds and thousands of tenants, like really large number. So Cognito supports really large number of user pools, but you could end up hitting some kind of a limit, right? So that's one downside. But if you have the need where you want to have different controls, different password policies, MFA, like multi-factor authentication for at the tenant level, user pool per tenant model is a really good approach. And also it gives you that isolation, right? Things are user pools are secure by default, but you never know, right? So a user pool per tenant gives you that isolation as well.
Right, and it doesn't really drive cost either to split it up in different user pools, right?
It doesn't. It's the same. From a cost perspective, it's still the same.
Yeah. All right. So this is happening behind the scenes now.
This is what is happening. So we onboarded this tenant, SaaS Coffee, that wants to sell coffee, right? So they want their own storefront with the SaaS provider. So we are registering the tenant right now. And the final bit of the registration, or part of the registration, is where we deploy the tenant's backend services. And we use the Amazon Code Star. We use Code Pipeline, Code Build, services, Code Commit, to manage that deployment process, right? So this is where we would create, the namespaces, and we would create a service account for that namespace for that tenant, and we associate that to an IAM role, for additional security, right? And then, so that's how we configure isolation. So what's happening right now, or what would have already happened, because we have been talking about this. It went through all this registration, created a CloudFront alias for SaaS Coffee, the new tenant, created a user pool, and added. So you can see there's a tenant management service calling a DynamoDB. It's basically storing all the tenant details in a DynamoDB table, and then finally we are kicking off this code pipeline, which is responsible for creating this Kubernetes namespace, the EKS namespace within the cluster for every single tenant, and deploy the product and order microservice for that tenant. So that's what is happening right now.
So let's jump over to the console then and have a look at
what it's actually doing. Absolutely. So what would have happened is, like I said, code pipeline. If I go to code pipeline, it should have, there you see SaaS Coffee is the pipeline, and it's in complete state. So it's a two action pipeline. So first, it downloads the code from Code Commit. Code Commit is it's AWS's code repository. It's a tool, and then there's Code Build, which is where all the steps. So if I tail Code Build, and this is where you're going to see some of the steps that actually happened as part of this. So you can see that a namespace was created, which is SaaS Coffee, right? And then using EKS Scuttle, which is the other tool that I was talking about, you create a service account and associate that to the namespace, right? And this is a sort of a deeper concept in itself. And a service account lets you have just controls over what the services or the pods or the containers running inside that namespace can access and cannot access, right? So we create that, and I can, if you have the time, I can go over that, or you can do it in a subsequent session. And so we do that and just deploy the microservices. If you see here the highlighted line, we deploy the product service, and we deploy the order service, and finally we create a network policy. And this is something that I haven't covered right in the solution yet. We haven't talked about, Gunnar. So there is this whole concept of a network policy, because what we see is namespaces. The Kubernetes namespaces are it just provides a logical abstraction or a logical boundary, right? It doesn't provide a it doesn't provide a strict concrete boundary, right? So if you have two services, a product service and order service running in tenant one namespace and tenant two's namespace, you have the same its own product and order service. They're still able to access each other by default, right? So that's the default behavior, how the Kubernetes networking works. So you'll have to apply like a network policy to basically, and I can show an example of that if I can pull it up. So the network policy would just restrict the communication between the namespaces. So when we create a namespace, we also create a network policy and apply it to that namespace so that we can say, okay, don't allow communication from any other tenant's namespace because we want that isolation built in. So I'm going to apply this network policy. And we are using an open source solution for this. Tigera Calico is the network policy plugin provider that we are using for the solution. But it's a really important concept, especially if you're looking for isolation, and isolation is a big aspect of a SaaS product.
Right.
So, yep.
Yeah, go ahead, Ranjit.
No, I was just going to show you, the tenant. So I have some. So I'll just change this because what we are looking for is a subdomain that looks like this, right? saascoffee.awsdevshop.com, because this tenant wanted to have their own storefront because they wanted to sell, coffee, right? So this is how it looks like. So remember I said, and let me quickly open Cloudfront, and if I can refresh Cloudfront, and remember I said there will be 3 distributions, and one of the distributions. So there's a landing application, there's an admin application, and then there is SaaS application. And if I open this distribution, you can see that there's a new alias in here for SaaS Coffee. And the registration service actually did this as part of that, registration. And then if I go to the Cognito console, and you can see that there's a user pool for SaaS Coffee. And you can see that there's a user and it's my email address, and there's, right. So this is the user that we provision, and it says to change password, and this is Cognito's behavior. You can control it because what it's going to do is if I try to log in here, it's going to ask me or prompt me to change my password. So if I go here, and I actually have to go to my email, which is on my other screen. So let me see if there was a temporary password email that I received. Yes, I do see a temporary password. So let me quickly log in. I don't know if that was right. Hopefully this works. There we go. So I'll change the password based on the standards that Cognito requires you to have, and then you are inside the application, right? And you can see that there is a product. You're able to add a product. I would say, add some coffee. I'll say $10, and then I'll just submit. A really simple e-commerce, right? And then you have a product, right? So and then you can create an order. Your customers can come, so they can say, okay, I want that many numbers, and then just submit an order, and they're going to see it. Really simple. I mean, but it's still an end-to-end application. You can see that there is it still has all the features, and there's users. You can see that now. The only thing is, if I go to Cognito and if I refresh this, you see the account status has changed to confirmed. It was forced change password, right? Because I changed the password, and you're able to see that. And you can add, like if you're the tenant admin, you're able to add users here. If you want other folks in your company to access this application, you're able to add this user. And we use AWS SDK and APIs to do that. So here you go, right? So you have the tenant application. I don't know if you have the time, Gunnar, but there's just one thing that I wanted to show, which is something that we didn't have the time to cover, and hopefully we'll have more time, which is, so when I create a product, you can see that every product call that goes out, if I go to one of these calls, we attach a bearer token, right? So this is what controls or enables authentication in our example. And again, this probably requires its own sort of session. But this is a layer of security that we have added. So every request that goes from client application to the backend EKS cluster and to the services in the cluster inside the namespaces, we require to send an application token, and the services are expecting that token. If you don't send a token, it's going to reject that request, right? It's something very important for SaaS applications or SaaS product. You need to have a good authentication strategy, and passing in tokens is part of that strategy, right? So, and like I said, we can have a separate session just on authentication. So
I think so. Authentication, authorization with tokens and such. That's a topic for an entire hour, I think. So, but it's good to see that that's in place. There's a quick question from the chat, by the way. Do you create one table per tenant, like one order table per tenant, or is it shared or isolated via roles? So that data isolation.
Yeah, so that's a great question, and we have a couple of models here, and we could, like I said, we could do a dedicated session on data isolation, because what we do in this example is we want to show an example where you have both the strategies, right? So we create an order table for every single tenant, just to show that you could have it's a perfectly valid model where you want to have a table or a database per tenant. So that's a strategy that we have seen. But also you may want to share a table, which is in this case it's a product table, and you're sharing the product table among multiple tenants, right? So we are using both the models, and I believe the second part of the question was, it is isolated because what we do is, so remember I talked about creating a service account. So when I created that service account, I associated a policy to that service account that said this particular tenant, let's say it's tenant 1, right, can only access their table. Like in this case, it's order-tenant one table. So we onboarded a tenant called SaaS Coffee, right? So if I still have that console open, I don't know if I have it open. Yep. So it's right here. So remember I talked, so this is the service account that got created. I'm also attaching a policy that says, and this particular policy would control access or restrict access to a specific tenant table. And that's what we are sort of isolating, because if an order service from a different tenant's namespace tries accessing this table, tenant 1's table, they're going to be rejected. So that's not going to work. So that's how we enable isolation in that model.
All right. So in this reference architecture, you're using different models, which is great for reference, so people can
take a that was the idea.
Yeah. All right. So we're reaching top of the hour, Ranjit. So it's time for wrapping up. So some final things around the solution. Just get people to try it out, I suppose.
Yeah, exactly. Just get people to try it out. It's open source, like I said, so you're able to clone the repo, just download it and just spin it up. If you find something could be improved, things could be changed, please feel free to create a pull request against the repo, and we're happy to take a look. But otherwise, just try it out. And there's also this blog and the developer guide, that we shared. So take a look into that as well. So. And provide feedback. Like, we are looking for feedback. Yes. So please,
just you can open issues on
open
GitHub.
Issues. Absolutely.
Away. All right. So with that, thank you very much, Ranjit, for joining us today and walking us through the multi-tenant SaaS solution built on Amazon EKS. And we have several topics we're able to deep dive on later on, just from this session. So for next week, or in 2 weeks rather, we're going to do a similar session, but on a serverless SaaS solution. So do join us then. So with that, my name is Gunnar Grosch. I've been joined by Ranjit Raman. Thank you all for watching, and hope to see you again in 2 weeks. Bye-bye.
Thank you all.